Welcome back, guys. Today we're going to start looking at volume. So in 10.4 we looked at the surface area and lateral area of prisms and cylinders, and then in 10.5 we looked at the surface area and lateral area of cones and pyramids, and so we're going to jump over to volume now. So we're going to start with prisms and cylinders. We're just going to start with a cube. You've probably seen that before. A cube, all of the sides are the same, so you literally just take the side times the side times the side, which gives you the side cubed. So that's specific to a cube. But if you want to know the volume of a prism in general, all you have to do is take the area of the base. So again, you might have some pentagons or octagons or things that the area is a little bit more difficult. I'm not going to do those in the notes today, but you might see those in homework problems or quiz problems or other type of problems. So go back and make sure you know areas of, circles, squares, rectangles. Those are the more basic ones, but also triangles and pentagons and octagons and all of those. So volume is just the area of the base times the height of the shape for a prism. Same exact thing for a cylinder. So volume is the area of the base times the height. They kind of put in here the area of the base for the cylinder if you wanted to kind of have that times the height, but really it's the same thing. You just have different areas of the base depending on what the bottom of the shape is. So this is called Cavaliere's principle. It sounds fancy, but it's really not that complicated. All they're trying to say is these shapes look different, but if you notice, this has an area of 6, this has an area of 6, and this triangle, also has an area of 6. 6 times 2 is 12, divided by 2 or times 1/2 gives you 6. So it's saying if they have the same height, and the cross section is the same at every level, or every bread slice is the same, then the volume of the whole thing is the same. So these three shapes actually have the same volume, even though they look a little bit different. So a composite space figure or composite figure is just if you take two or more figures and combine them. So maybe you have a can. Let me see if I can draw that. A cylinder, canned good. And on top of it, you have, let's say like a party hat or a cone. We saw this in one of the other problems we were looking at with surface area. But with volume, all you got to do is take them each separate. So, boom, move this off. Take them each separate and find the volume. And then add them together. So whether it's on top or side to side, when it's volume, or how much water you would fill up with it, or how many beans, what the volume of beans in that can is, that is going to be basically them added together. So with this section, really, you just need to practice these. So I'm going to do some of them with you. There are 9 practice problems. I wrote all of the answers out so that you can pause the video. If it doesn't work to pause and skip around in Edpuzzle, you can look at my YouTube channel. I think that link is in Classroom somewhere, or just search Maggie Sperber on YouTube, and you will find my YouTube channel, and then you can pause some of those and try to do them yourself if you want some extra practice, and then check the answers. So we'll do a couple of them together. So let's get light pink. Number out of 1 and 2, they're both rectangular prisms, so I'm just going to do one of them. Let's start with this basic one. The volume is just the area of the base times the height. So that volume, the area of the base is a rectangle, so length times width, or base times height, 15 times 5, and then the height is 3, the height of the 3D shape. So type that all into your calculator, and you should get 225 And then the unit is cubed because it's three-dimensional. So centimeters cubed. Number 1 is similar to that if you'd like to try that on your own later. If you have, these are both triangular prisms. So if your base is a triangle, this one doesn't look like the base is the triangle because the triangle is not on the bottom, but the base is always the piece that's parallel, that are matching. So if you slice this up, you would get triangles. So that rectangle on the bottom is not actually the base, that's just one of the sides. This is a triangular prism on its side. And this block of cheese looking thing, this triangle is the base, because it is the piece that has a parallel matching shape. So these are the bases. So we'll just do one of these. Same formula, volume is the area of the base times the height. I suppose I should write volume out. And you just have to remember the area of a triangle is 1/2 times base times height of the triangle. This height is the height of the triangle, but this height is the height of the triangular prism, so be careful there. So I'm going to do that one step at a time. I'll write it out. 1/2 times the base of the triangle is 35, and the height of the triangle is 7. And then the height of the whole prism is 18. So I would just type that into my calculator. 1/2 is 0.5 times 35 times 7, and then times 18. And that gives me 2205. And then again, our unit is millimeters and cubed because it's three-dimensional. Number 4 would be the same sort of thing. You can try that on your own if you'd like. Okay, cylinders. The only difference here is this one has a decimal. So if you'd like to do that in decimals, you can, or you can convert it to a fraction. I think it would be 17/2. But let's go ahead and do this one. This is still a cylinder. It's just on its side. So you've got a canned good. It's just sitting sideways. So they gave us our radius. If they gave you diameter, you could solve for that. But the volume is still the area of the base times the height. So in this case, area of the base is pi r squared because it is a circle. So the volume is pi times 2 squared, and then the height is 10. 2 squared is 4 times 10. That gives you 40 pi millimeters cubed, or if you want decimals, that is 125.66. And again, if you'd like to try the other one, you can. Okay, I'm going to do these last 3 because they're a little bit trickier. This one is like a cylinder, but it's only 3/4 of the cylinder. So I'm going to find the volume of the cylinder, which is, again, the area of the base times the height. And that base is only 3/4 of a circle. So I'm going to take pi r squared, but I'm going to multiply it by 3/4. And then again times the height. So that would be 3/4 times pi. The radius is 5, so 5 squared, and the height is 10. So I'm going to do a little bit of math without my calculator. 5 squared is 25 times 10. That's 250 times the 3. So I'm going to get 750 on top and 4 on bottom. Which reduces to 375/2 pi. If you want to just type that all in your calculator and get a decimal, that's fine too. And you would get 375 divided by 2 times pi, which is 589.05. This one asks for a whole number, so 589. And then your unit would be feet cubed. Again, the cubed is because it's in 3D, or it's feet times feet if you look at it. Area of the base is feet squared times the height, which is feet, so you'll get feet cubed. This one, you have two different volumes, and you're subtracting out the inner one. So real quick, for the inner one, they gave us the diameter, which is 2 radius. The diameter is 4, so that radius would have to be 2. So I'll color this one in orange. Nah, I'm not feeling orange. Color this one in pink. Yeah. Okay, so that pink one, again, the volume is the area of the base times the height. And that area of the base is a circle. Again, it's like a canned good, but it's on its side. The bases are the circles because they're parallel. So that would be pi r squared times the height. And that radius is 2, and the height is 18. So that volume would give you, 2 squared is 4. 4 times 18 is 72 pi inches cubed. Then we can look at let's look at this purple shape, which is this cube, or sorry, not cube, rectangular prism. And that is the whole entire volume. And so again, still area of base times height. But this time it's a square base or a rectangular base. So I'm going to look at this as the base. This one, it doesn't really matter what you look at as the base because it's rectangular. So they all have parallel pieces. But just to be consistent with the cylinder, I'm going to do that. So the area of the base would be 10 times 8, or length times width. And then the height would be 18. So if I do that, I get a volume of 1440 inches cubed. So to find, if I erase all of this, if I want to find basically that box without the cylinder cut out, I need to take the purple and I need to subtract the pink. So I would just take this and subtract this. And then, oops. Your answer, you could leave it like this, 1440 minus 72 pi inches cubed. Or you could say the volume is 1440 minus 72 pi. Type it in your calculator, and you'd get 1213.81 inches cubed. And this one asked for the whole number, so I'm going to go ahead and follow their rounding rules and get 1214 inches cubed. Okay, the very last one, I wanted to show you guys this one. The rule is still the same. Volume equals area of base times height. And again, that base is actually a triangle. Even though it's not sitting on its base, that's the piece that's parallel. So those triangles are the bases. It's just kind of sitting sideways. This time they gave us the volume and they want us to work backwards. So that's why I kind of did this one. So our area of our base would be the area of a triangle, 1/2 base times height, which is 8 times 8. And then the height of the whole prism, which is different than that height, is actually x in this case. But we do know that the volume of the whole thing equals 576. So I can say 576 equals 8 times 8 times 1/2. That's 32 times x. Divide both sides by 32, and that gives me 18. So 18 centimeters should be that height. And you can double check by going back and saying, okay, if I plugged it back in, would I get 576 to make sure you're right? So I went through those kind of fast just because I wanted you to see roughly how to do them. But really the biggest thing with volume, since the formula is not overly complex, just area of the base times the height, is just practicing them. So if you want to practice some of these now, you can. Otherwise, you can work on the homework. I'm going to zoom in on each one of them in the answer key so that on YouTube you can pause it if you'd like. So here's number 1. And here's the answer for number 1. Here's number 2. And here's the answer for number 2. Here's number 3. And here's the answer for number 3. Here's number 4. And here's the answer for number 4. Here's number 5. And here is the answer for number 5. Here's number 6. And here's the answer for number 6. Here's number 7. And here is the answer for number 7. Here's number 8. And here is the answer for number 8. Here's number 9. And here's the answer for number 9. So again, if you want to go on YouTube and pause those and try those on your own, go for it. Otherwise, here is your homework for practice. Have a great day. Bye, guys.